Here we have a pre-calculus problem on logarithm. Okay, let's go to the question. If log x equals to m positive n and log y equals to m negative n, then log 10x over y square equals to. Okay, so among the given options, we have to find the expression which is equivalent to this logarithm. Okay, so first let me take the given logarithm, that is log 10x over y square. Here, the argument of the given logarithm, two quantities are in division. Whenever two quantities are in division the argument of logarithm, so I have to take logarithm for numerator and denominator separately and subtract them. This is a coefficient rule of logarithm. Then I'll be getting log 10x positive log y square. Okay, here in the first logarithm, so in the argument 10 and x are multiplied. Here two quantities are multiplied. So whenever two quantities are multiplied in the argument of a logarithm, we can take the logarithm separately for each quantity and add them. This is a product rule of logarithm. Then I'll be getting log 10 positive log x. And here the third logarithm, the argument is exponential. So if the argument of a logarithm is exponential, the exponent over here can be moved in front of the logarithm and it has to be multiplied by the logarithm. Then I'll be getting 2 times log y. So this is the power rule of logarithm, that is moving exponent in front of the logarithm. Okay, here, so for the given logarithm, the base is not mentioned. So for a logarithm, if the base is not mentioned, we have to understand it is a common logarithm and its base is 10. So for the first logarithm, I assume the base is 10 because the base is not mentioned. It's a common logarithm. Okay, in a logarithm, if the base and the argument are equal, the value of such logarithm is just 1. So log 10 to the base 10 is just 1. And here we have to notice an important thing. So just consider the logarithm, so where the argument is 1. So the value of logarithm which has argument 1 equals to 0. So here the base is not mentioned. Here any base you may have. Okay, so the value of this logarithm is 0 because the argument is 1. In a logarithm, if the argument is 1, so whatever base we may have, so the value of such logarithm is 0. Okay, what if log 1 to the base 1? Its value is also 0. So you may think, so here the base and argument are same. So the value of such logarithm must be 1. No. So because the argument is 1. Except this case, let's consider some other logarithms where the base, where the argument and base are same. Its value is 1. So log 3 to the base 3, its value is 1. ln e. So it's a natural logarithm because whenever we have the spelling ln, it's natural logarithm. Its base is not mentioned. We have to understand its base is e. So this value, the value of this logarithm is also 1. So only for this case, that is where the argument and base are same, but the value of such logarithm is 0. The reason is the argument of the logarithm is 1. So all other cases except where the argument is not 1 and also the base and argument are same, the value of such logarithm is 1. So in our case, the base and argument are same and also the argument is not 1. So the value of this logarithm is just 1. Okay, now what we can do is 1 positive. For log x, we have the stuff m positive n. We can plug in m positive n for log x, and 2 times for log y, we have m negative n. We can plug in that stuff for this log y. Okay, 1 positive m positive n. Now I can distribute this 2 to m and negative n. Then I'll be getting positive 2m and negative 2n. And now we can combine. When I combine this m and positive 2m, so I'll be getting positive 3m. When I combine this positive n, negative 2n, it will become just negative n, and at last I have just 1, it's positive 1. So I just got the stuff which is equivalent to the logarithm, that is log 10x over y square, that is 3m negative n positive 1. I find this stuff in option B. So the correct answer choice for this question is option B.